Today we are going to focus on understanding confidence intervals. This video is about meaning, not math. You are not expected to memorize formulas or do calculations by hand. The software will do the calculations. What matters is that you understand what a confidence interval is, what it tells you, and how to explain it clearly using words. A confidence interval is a range of values that we use to estimate something about a population. The value we are estimating is called a population parameter. A population parameter is a number that describes the entire population, such as the true average test score of all students at a school, or the true percentage of customers who would recommend a company. These values are fixed, but they are usually unknown. Because we usually cannot measure every individual in a population, we collect a sample. From that sample, we compute an estimate. But samples are imperfect. If we took a different sample, we would get a slightly different estimate. A confidence interval accounts for that uncertainty by giving us a range of reasonable values instead of a single number. This is where the idea of confidence becomes important. A confidence level is usually stated as 90%, 95%, or 99%. The confidence level describes how reliable the method is when it is repeated many times. Imagine taking many samples from the same population using the same method. For each sample, you calculate a confidence interval using the same confidence level. If you use a 95% confidence level, then about 95% of those intervals would contain the true population value. This point is very important, so we are going to say it again in a different way. The confidence level does not describe how confident you personally feel. It does not describe the chance that the value is inside the one interval you computed. The population value does not move, and it is not random. What changes is the sample. Different samples produce different intervals. Some intervals capture the true value, and some do not. The confidence level tells us how often the method succeeds over the long run. A common incorrect statement is, there is a 95% chance the true value is in this interval. That sounds reasonable, but it is not correct. The correct idea is that the method produces correct intervals about 95% of the time, when it is repeated many times. Now let's talk about what a confidence interval looks like. Every confidence interval follows the same basic structure. It is an estimate plus or minus a margin of error. The estimate comes from the sample. It is your best single guess for the population value based on the data you collected. The margin of error is how much uncertainty you are allowing for due to sampling. You can think of the estimate as the center of the interval. The margin of error tells you how far the interval extends to the left and to the right of that center. For example, suppose your software gives you a confidence interval that goes from 72 to 80. The midpoint of that interval is 76. That midpoint is the estimate. The distance from 76 to either end is 4. That 4 is the margin of error. So you could describe this result as 76 plus or minus 4. The margin of error helps you understand precision. A small margin of error means your estimate is very precise. A large margin of error means there is more uncertainty about where the true population value lies. Three things control the margin of error, and each one affects the width of the confidence interval. The first is the confidence level. Higher confidence means a larger margin of error. If you want the method to work more often across repeated samples, the interval has to be wider to make that happen. The second is sample size. Larger samples lead to smaller margins of error. When you collect more data, the estimate varies less from sample to sample, so the interval can be tighter. The third is variability in the data. When the data values are spread out and inconsistent, the margin of error is larger. When the data values are more similar to each other, the margin of error is smaller. It is also important to understand how sample size works. Increasing sample size reduces uncertainty, but it does so slowly. Doubling the sample size does not cut the margin of error in half. To make a noticeable reduction in margin of error, you usually need a much larger sample. This is why confidence intervals do not shrink dramatically when you only add a small number of observations. Now let's look at a detailed example using a proportion. Suppose we want to estimate the proportion of students at a college who have taken an online course. This is a yes or no question. Each student either has taken an online course or has not. We randomly sample 200 students. Out of those 200 students, 110 say they have taken an online course. Based on this sample, our estimate is that a little more than half of the students have taken an online course. In the software, you would enter the number of students who said yes, the total number of students in the sample, and the confidence level you want to use, such as 95%. The software then calculates the confidence interval. Suppose the software gives an interval from 48% to 62%. Here is how to explain that result correctly and completely. At the 95% confidence level, we estimate that the true proportion of all students at this college who have taken an online course is between 48% and 62%. This interpretation includes several important pieces. It includes the confidence level. It names the population. It states what value is being estimated. And it gives the range of plausible values. All of those pieces matter. We can also describe this interval using margin of error. The estimate is about 55%. The distance from the estimate to either end of the interval is about 7 percentage points. That means the margin of error is about 7%. We could say the estimate is 55% plus or minus 7%. Now let's think about why this result makes sense. If we increase the confidence level from 95% to 99%, the interval would become wider. The data would not change. The estimate would not change. The only thing that changed is how reliable we want the method to be. Higher confidence requires a wider interval. If we instead increase the sample size while keeping everything else the same, the interval would become narrower. More data reduces uncertainty, so the margin of error gets smaller. Now let's switch to a different type of problem and look at a confidence interval for a mean. Means are used for measured data, such as time, height, or scores. Suppose we want to estimate the average number of minutes students spend commuting to campus. We take a sample of 25 students and record their commute times. From this sample, we calculate an average commute time of 32 minutes. In most real situations, we do not know the population variability exactly. Because of that, the software uses the variability from the sample and adjusts the interval to account for that uncertainty. You do not need to calculate or control that adjustment yourself. The software handles it automatically. In the software, you would enter the data or the summary information and choose a confidence level, such as 95%. The software then produces a confidence interval for the population mean. Suppose the interval goes from about 28 minutes to about 36 minutes. Here is the correct interpretation. At the 95% confidence level, we estimate that the true average commute time for all students is between about 28 minutes and about 36 minutes. Now we need to be very careful about what this does not mean. A common incorrect interpretation is that 95% of students have commute times between 28 and 36 minutes. That is not what this interval describes. This interval is not about individual students. It is about the population average. Individual commute times could be much larger or much smaller than this range, and the confidence interval could still be correct. The interval is describing uncertainty in the estimate of the mean, not the spread of the data. We can again connect this to margin of error. The estimate is 32 minutes. The distance to either end of the interval is about 4 minutes. That means the margin of error is about 4 minutes. We could say the average commute time is estimated as 32 minutes plus or minus 4 minutes at the 95% confidence level. Now let's talk about the role of software more clearly. The software performs calculations, but it does not think for you. It does not decide what you are estimating. It does not decide whether a proportion or a mean is appropriate. It does not check whether your interpretation makes sense. It will always give you an answer, even if the setup is wrong. That is why understanding the meaning of confidence intervals matters. To use confidence intervals correctly, follow a clear process. First, decide what you are estimating. Is it a proportion based on yes or no data, or a mean based on measured data? Second, Choose a confidence level that makes sense for the situation. Third, enter the correct sample information into the software. Fourth, explain the interval using words. Always include the confidence level, the population, the value being estimated, and the range of values. Confidence intervals do not give exact answers. They give honest ranges that reflect uncertainty. They are one of the main tools statistics uses to connect samples to populations in a clear and meaningful way.